Alrighty, welcome back to 105. Hopefully everyone had a restful reading week. And hopefully everyone is ready because it is midterm eve. That's scary, huh? So, a little, I guess, admin stuff out of the way. I have to proctor some of the exams tomorrow, so I'm just staying on campus late. So I will have extended office hours from like 4 to probably at least 7 in my office, BA 5110. If you want to ask me questions, I should be there anyway, anywhere from 4 to about 7. And there's like 12 to 20 chairs outside my office too, if you want to study there. Up to you. So before we start, any pent-up questions or anything? I've only gotten one request to do something, so. Everyone okay that is currently sitting here before I just start doing random other review things? Yeah. Sorry? Pascal's triangle? Like, that's a question on one of them? Can I do it? Yeah, sure. So, I have a few set up. So one request is for Pascal's triangle. Is that one we already have? So let's see. So if you look at the examples repository, I have a bunch of code that goes into some examples that were on past midterms that may have a different style of solution than what is currently given to you. So has same numbers. I made up some example today. There is a palindrome. What's the largest sum? What's the number of bits of a number? Print out the order of the array with the second digit. What are the Pythagorean triples? Things like that. So, first question I had, I guess that was someone asked on Discord. It's like, hey, let's have some example of like array questions or pointer questions or things like that. So, unless it's kind of hard to force you to use pointers if you don't really want to, unless we like say the function has to, have this prototype and you need to change 2 variables or something like that because you can only return 1 value by default for a function. So if you want to, return 2 things, you have to do it by pointers because you can't return more than 1 thing at once. Or try and force you to use arrays. So usually, if you want to use arrays in your code, that's up to you. If we want to kind of force you to use arrays, we might give you a question like this. So we would give you like, hey, here is a function signature. Here's a prototype for a function. It needs 2 arguments, an array of ints called number, and the length of that array given by the second argument, which we call number's length. And then it might be just be like, hey, write the function to get the average of all the numbers in that array. So we would be given, it's on Quarkus, so we'd give you this function prototype. You just go ahead, copy and paste it into VS Code. You'll have VS Code. Hopefully you did all the mock test, so you can copy and paste that into VS Code. Then just change the semicolon to curly brackets so we can start defining this. So in this, if we want to take the average, right, it would probably give you the equation for an average, but we probably all know what it is. You just sum all the numbers together and then just divide it by how many there are. So to do this, a few different ways. I can sum it all together in an int. I could sum it all together in a double. We're going to have to be a little careful about this, about truncating things weirdly. So if we do something like int, let's say int sum, so we just have a variable keeping track of our sum, initialize it to 0. And then typically for arrays, you're always going to be iterating over every single element. So you're going to be using a for loop, and it's probably going to look like this. For int I equals 0, I is less than number's length, plus plus I, or I plus plus. Again, doesn't matter in this context. It will just increase I by 1 at the end of the body of the loop. Then we would do something with every single element. So in this case, every single element, we'd use the square bracket notation to access every single element. Or if you wanted to, right, we could be weird about it and we could do numbers plus I, so that's some arithmetic pointer arithmetic to point to that index of whatever that number is, and then we would have to go ahead and dereference it. So we could do something like that if we wanted to, get the actual number. If we didn't like the square bracket notation for whatever reason, they're equivalent, but unless something's trying to trick you, probably in your case a short answer question, you can just go ahead and use something like this. So number is I. So I'm going to go through sum everything together. So I could do sum plus equals. I could do sum equals sum plus numbers I. Again, lots of different ways to write this. And then at the end, I could return sum divided by numbers length. So is this a good solution to this, or does this have any possible problems? Yeah. Yeah, I have two ints there, right? So if I have two ints there, that's integer division. It might truncate something, which might give us a result that we don't quite expect. We might want to be more exact than that. So there's two different ways to do it. I could either explicitly typecast the first. So right now, sum is an int, numbers length is an int. So int divided by int will be truncated division and return you an int. If I wanted to force it to double, I can explicitly typecast sum to a double. So remember, double, this takes higher precedence. So it will change sum, change it to a double, and then it's a double divided by an int. So the rules are, if you do a double with an operation with something that is not a double, it will implicitly typecast it to a double. So this will be typecasted to a double implicitly, then we get a double divided by a double. We don't lose any precision or anything like that. So that's one way to do it. Another way to do that is I could just, just define sum as a double if I wanted to. And then that removes a typecast at the end because sum is already a double. That's double divided by an int, something like that. So questions about that? That gives you some little things to look out for, and possibly being the one that wrote the question about arrays, it probably looks something similar to that. Wow, I need to shut up. Yeah. Yeah, so the difference, the question is, what is the difference between plus plus I and I plus plus? So the difference in this case, if you don't use the value of the expression, there's no difference between them. The only difference is going to be if I do something like this. If I have int x equals 1, here, let's do it in main so we can actually see the result. If I have int x equals 1, and then I do printf, x equals, or I could just say question mark equals digit, and I could do plus, wow, okay, I should just look at my actual screen because there's a weird delay. So I could do something like this. Oh, let's name them something first, second. So this is where the difference between plus plus x and x plus plus will come into effect. So anyone want to guess what this will output? Yeah, 2, I hear 2. What's the second one going to output? 1? So it's not going to output 1 because we would have changed the value of x in this line from a 1 to a 2, right? So let's print it again. So x, so I'll do something like this. So I'm going to say, so initially x is equal to 1, then we have plus plus x. So the change to x after this plus plus x gets executed is x is going to increase from 1 to 2. So in plus plus x or x plus plus, at the end of either of those, x is going to increase by 1. It's just what's returned as part of this expression. So plus plus x is going to increase the value of x from 1 to 2, and this plus plus x is going to return the value of x after doing the addition to it. So in this case, if we increase x from 1 to 2, it's going to return 2. So first is going to equal 2. And then if we do x plus plus, again, that will change the value of x from 2 to 3. But the rule with plus plus at the end is it returns you the value of x before it did the addition. So in this case, it increased x from 2 to 3. So this is going to return 2. And then at the end here where we just print off x, well, in either case, it added 1 to x. So this should print off x is equal to 3. So let's make sure that that works. So I just called this what? Average. So indeed, I'm correct. So it went 2, 2, 3. But at the end of the day, if you come in a situation where this matters, it's probably either trying to be like a tricky multiple choice question or a true-false question, or you have written your code weirdly. So usually, if it matters which one you use, you have done something weird. Because in here, this plus plus I, we don't use the value or the result of that expression anywhere. We only care about I changing. So if I change this from plus plus I to I plus plus, doesn't matter. I just out of habit always use plus plus the variable name because that's usually what you expect it to do. And also in certain cases, x plus plus can run slower because it has to basically remember the original value of x, which might slow down your code in some circumstances. So should be, unless you have a good reason not to, always prefer plus plus variable name. All right, any other questions with that? Fun, fun, fun. All right, so because someone asked me about arrays and pointers, I came up with this question that is probably too long and too complicated for you to actually do on a midterm, unless it counts as like several parts or something like that. But we can try it. So the question might be like, hey, given two lines of the form, you know, y equals mx plus b, so you get an m and a b from two lines, figure out whether or not the lines intersect. And then if they intersect, you want to return the x and the y of their intersection. So we can't return two variables, or in this case 3, because we want to return from the function itself whether or not the lines intersect. And if the lines intersect, we want to actually record the value of their x and y at the intersection through those pointers, dereference them, and change the value. So for this, I mean, we would have to do a bit of algebra, but I mean, you'd be given that stuff, or I don't know, maybe it's outside the scope, but in order to see if two lines intersect, right, we set them equal to each other, then we can solve for x. So we got m1 times x plus b1 equals m2 times x equals b2. You know, bring b1 to the other side, bring the m2, the x to the other side, collect like terms, and then you can divide it over divide both sides by m1 minus m2. And like with normal math, right, we'd have to make sure that m1 does not equal m2. Otherwise, we divide by 0, and that's how you can prove that, you know, 0 equals 1 or something stupid like that. So this is only valid in the case that m1 does not equal m2. And then, oh, that gives us a bit of a hint. If m1 is equal to m2, it means the two lines have the same slope, which means they are parallel, which means they will either never intersect or infinitely intersect, right? And we only want a point. So for this case, we'll just consider that condition. So if m1 equals m2, we'll just assume that the lines do not intersect, right? They're either, we'll just include the, you know, directly over top of each other being the same line as actually not intersecting. We'll just assume that, you know, it's infinite. Could argue that whether or not that should be an intersection or whatever, so I'll just ignore that for now because we want to return just the unique point. So after that, we can actually solve this equation, right? So if the lines aren't parallel, that means by definition they have to intersect. So I can change my return to be false, or my return to be true, so I know they intersect. I can actually solve this equation. So I just can go ahead, dereference x, because I want to write the value of x to somewhere, and I just write it out from this equation. So it's just b1 minus b2 divided by m1 minus m2, and have a semicolon at the end. So that would be my x-coordinate, right? All right, my y-coordinate, well, I figured out x. I can just plug that value of x into either equation. It doesn't really matter, so I could do y equals m1 times whatever the x I found was plus m or b1. Doesn't matter, whichever one I can choose. So that will return false if they're parallel on top of each other or not on top of each other, and then should return, oh, if there's an intersection with their x and y's. That okay with everyone? All right, so we can compile that. We would probably give you some little demo code. So here is a main. I believe we give you a little bit of a main. If not, you can, I think we do give you a bit of a main so you can actually test your function. So in this case, I'd have a main. I'd have, double x, double y initially set to something, then double m1, double m1, b1, double m1, b2, and then I can test my function. So if the lines intersect, then I give them, the address of x, the address of y's, and if the lines intersect, I print off the value of x and y because that function changed those values. Otherwise, if it returns false, I just say no intersection. So if I go ahead, if I go ahead and run that program, what the hell is it called? Build intersect. So it should say that they do intersect. So questions about that before we turn it up to more fun. All right, so more fun would be like, hey, there's different styles we could do. Doing what I'm about to do and implementing everything would take too long. But maybe we flip this a little bit and say, hey, we give you this lines intersect function that does exactly what we described there, so you don't have to write it to save you a bit of time. And we can be like, hey, well, maybe we want you to write a function called all lines intersect, where we give you an array of m's, an array of b, such that, at the same index that corresponds to a line, tell you how many lines there are, and then gives you the x and the y. So this should only return if all of the lines intersect at a single point, not just two, because, well, if they're not parallel, two lines will always intersect. Who knows if three lines actually all intersect? So to do this, this combines arrays and pointers in the only, way I know how to make you how to force you to write it. Again, this will probably be too hard for the actual midterm, but we could go ahead and do this. So what we could do is leverage our lines intersect function. So question will probably be something, assume there's always at least two lines, otherwise the question doesn't really make that much sense. So I can go ahead and just actually check, hey, if lines intersect, maybe I want to check if the first line, which is m0, b0, intersects with m1 and b1. So those are the first two lines, so I can find the intersection there if it exists. And if it exists there, then I actually have a hint that, okay, maybe I should continue on. If these lines intersect, then it's not possible that all of the lines given intersect if even the first two don't intersect. So x and y are given by a pointer. Here they're given by a pointer, so I can let this function set them. So here, all I really care about is when I call this function, if the lines do not intersect. So if the lines do not intersect, so I can just negate it. So if the lines do not intersect, that whole thing will be true. And then I know that, well, it's not possible that all of the lines intersect if the first two don't. So I could just do something like return false immediately there, right? I don't have to continue on. I don't have to do anything like that. So now with the first, assuming we make it here, right, we have our first intersection. So maybe I will think about this and be like, okay, well, I just have to check if every other line except the first two intersect with either the first line or the second line at the same point, right? So what I could do is, okay, I want to maybe keep track of that point that I just set. So this lines intersect function would have set the point if the lines intersect, which if we make it to this part of the code, they do. So maybe I save them. I just say first x equals dereference x, so I get the value, and then double first y equals dereference y. So now I'm saving the x and y of that first intersection, and now I can loop over every single other line. So for this, I can do for int I equals and think of the index I need to start with. So I already handled index 0 and index 1, so I don't have to start there. So I can start with any, like I want to start at the third line, right? So that is I equals to 2. Want to go until the end of, we're all out of line, so I is less than length, and then plus plus I or I plus plus, again, doesn't matter. Then here, well, I need to just check if, and for this, we can just start off with the condition. So see if the lines intersect. Again, I can use M, the first line or the second line, doesn't really matter. Let's use the first line and see if it intersects with the current line, which is MI and BI. And then this will go ahead and change the value of x and y. Here, let's hide this. So if these lines do not intersect, same idea that if, this line does not intersect the original line or the first line, then I can do the same thing again, right? I can do if not. So if those two lines don't intersect, I know that for sure all of the lines don't intersect, so I can just return false immediately. I don't have to continue on doing this code or anything like that. And other than that, I know that this ith line also intersects with my first line. So now all I have to do is check that, hey, the coordinates are actually the same. So I want to return false if the coordinates are not the same. So my first x was first x. So if first x does not equal what it just set, whatever found this intersection is, or first y does not equal y. So if either of those are false, then I know that, hey, this is not the same point that I found originally. So I can return false. Otherwise, if I make it to the end of the loop, I know everything has all intersected at the same point, and I can return true. Yep.
What about the case for when the lines are the same? Because for this one, if the first and the third lines are the same, then it'll return false. But if the third and the fourth line is the same, because you're checking against the first one, it'll return true.
Yeah. So the question is hey, if the lines are the same lines, then should we return that they are all, intersect at the same thing? And again, you could argue it that there has to be exactly one unique point solution, in which case this is fine. It would have to go up to the math wording of the question. So we probably wouldn't get you to do that or accept both solutions if it's something to do with math that you could argue it.
But the outcome of this function will change depending, it's not consistent.
The outcome of this function?
Because we're only checking against the first line, and our lines intersect function returns false if the lines are the same. So, but if two of the lines are the same later on, but they're not the same as the first one, then it'll return true. It'll be fine.
Oh, okay. Yeah, so the one note is like, hey, if two of the lines are the same, then we might actually not detect that they're the same if like one of the ith lines is the same as the first line instead of, or the line at index 1 instead of 0, right? So that's technically true. We will ignore it for now, just to make this not take forever. So typically, we try and word the question such that something like that didn't happen. This is why I'm saying this is probably way too hard for a midterm and has too many like wiggle room things. So yeah, you're right. That's why this question is not on the midterm and why I'm just saying it right now. All right, so if we do that, we could give you this code to test it. So usually the length will just be hard-coded at some value. Here, I'm lazy, so I just use that array length macro. You will not have access to it on the midterm unless you memorize it, which is a complete waste of time. You can just hard code the length of the array, or we give it to you anyways. So don't worry about that array length macro or anything like that. It's just handy dandy to have in your actual code. So if we compile that, now I have 3 lines. So here are my 3 lines. I can check if they all intersect. If I do this, I can say, oh, all the lines intersect at 2, 5. And indeed, if I do this, I can see that is true. If I want to check that my function works, maybe I change this value of my third and last line to start at y equals 1, which makes it not all intersect, and I can test it and it says, oh, okay, the second one, all lines do not intersect. All right, questions about that? Again, probably much harder than you will have to do. But this combines arrays and pointers which was asked of me in the only way I know how. So any other things we need to go over? Other than that, I'll just do the next trickiest thing I know, which is more of this stuff again. So most people get confused by pointers and stuff like that. So to practice the programming problems, best thing to do is just look at past midterms. Again, if you look at that examples repository I gave you, there's lots of code in there that have a different style than what's in the solution. Best way to learn code is by just looking at a whole bunch of code, trying problems over and over again. So just to get more mechanical practice, questions like this are good for figuring out how to argue about pointers and things like that. So this one, again, you will not be given this because you could just copy and paste the code, run it, and then you're good. Oh, yeah. Which midterm? 2020 question 7. All right, let's do this one quick. I'm not sure if I have 2020 on hand, but I can check it quick. So let's do this really quick. So with this, tracing what happens, again, with pointers and all that, first, we declare a whole bunch of variables, set their values and everything like that. So this declares an int called first. Current value is 1. Then an int called second. Value is 2. Then it creates an array called data. 0th element, it has 4 elements, so 0, 1, 2, and 3. I'll just write it around that code. And the initial values are 10, 20, 30, 40. So then next line, we create a whole bunch of pointers. So remember, for variable declarations with the stupid comma, the ampersand or the star does not carry across it, but in this case, every single name has an ampersand in front of it, so they are all 3rd, 4th, and 5th are all pointers to integers. So since there's pointers, I know that the value stored there is actually an address. So 3rd is just going to be some address. 4th is some address. And then fifth up here is some address. So how I always write this is everything in a box is a value, and then for pointers, I just draw arrows at what they're pointing to. So third, when we take ampersand second, that means we are getting the address of second, wherever that value lives in memory, and we're pointing to it. So third would point to second. Then fourth, well, they do ampersand first, so fourth is pointing to first. And then fifth, oh no, some fun pointer arithmetic. So data is an array. So there's array decay, and just data by itself, which is an array, will decay to a pointer, pointing to the first value there. So it would be initially pointing to whatever the value is at index 0. So then we do some addition. So we do plus first plus 1. So we need to get the value of first. Currently it's 1. So it's 1 plus 1, or just the same as data plus 2. So if we do pointer plus an int, that will just move it that many elements, is how pointer arithmetic works. And all the types line up, so we're all good. So this is data points at element 0, data plus 1 points at element 1, data plus 2 points at element 2. So this is what it is currently pointing to. So fifth is pointing, whoops, different color. So stop it. So fifth is currently pointing here. So next line that gets executed is we dereference third and then do plus plus. So to dereference third, whenever we dereference something, right, we're following the pointer exactly one step in accessing the value. So when we dereference third, we're following this pointer here and accessing this value. Whoops. Accessing this value, which in this case is a 2. So dereferencing third will give us that 2 value, and then that 2 plus plus, that will increase it from a 2 to a 3. Then for fourth, again, we dereference fourth. So we follow it. We follow its pointer to access the value that it's pointing to, which in this case is 1. Plus plus will change it from a 1 to a 2. All right, everyone good with that? Cool, so now we just have to figure out all of these. So dereference fifth. So if we dereference fifth, then what we have to do, again, follow the pointer of fifth here. So we follow it. It is currently pointing at the value 30. So this is going to be the value 30 plus first. So first is just the value of that variable. So currently it is 2 plus dereferencing third. So we'll follow third. It points to the value 3, so it is plus 3. And then we dereference fourth. So fourth is pointing to this 2 again, so it will just be 2. So this whole thing will evaluate to 34, and then it will change data at whatever second is. So second is currently 3, so this line executing is the same as data 3 equals 37. So data 3 is this value, which is 40, so it reassigns it from 40 to 37. Everyone follow that? Everyone good? Yep. 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 Yeah, so the question is, if I have data and data plus 1, so let's say int x equals that, int. So you're saying if I do this, okay, Apple Intelligence, you're not that smart. Like, why is this equal to 1? Yeah, so data, so in terms of addresses, so in terms of actual addresses, right, the address of X, so let's say it starts at like array plus 0, and in memory this would be like array plus 4 because an int is 4 bytes, right? But these are the addresses. And with pointer arithmetic, it will figure out the correct address just based off the size of whatever it's pointing to for you. So whenever you do pointer arithmetic, the pointer arithmetic is to the actual elements, not the memory address. So the way to think about it is like data, that's just the first element of that array, whatever that array is. In this case, it would be an array of ints. In this case, data plus 1 is a pointer to the second element, which is at index 1. It would be 4 bytes away from the first one because they're both packed together. But pointer arithmetic, it's element-wise, not bytes. Yeah. No, there will be no question where it asks, like, how many bytes away is this in memory or something like that. And no mixing of types or anything weird like that. Yeah. Yeah, if you mix. So, yeah, if I have like double z equals data, and I declare data like the same as this, where data is an array of ints, well, weird things are going to happen. Because if I do data plus 1, yeah, that's just going to do weird things because it will do the pointer arithmetic based off the type of this, which is an int. So this will be just like some address plus 4. While if it's pointing to a double, everything has to be 8 bytes apart. And basically, you'll just get a random answer of this. So you can technically do this, but you shouldn't mix types or anything like that. We won't ask you to mix types. That will come in later courses where the pain of C happens. Yeah. Yeah, so the question is, can I go over a pointer? We will not cover it on the midterm, don't worry about. We'll start doing that in our first lecture after the midterm, I think, or shortly after that. So don't worry about double pointers. Yeah. Do you need to write comments? Absolutely not. So if you don't want to write comments, then you don't have to. The questions will get graded by the TAs, so if your code doesn't work, to make sure you understand it, to help give you part marks or something like that, maybe having comments might help you a bit. But if your solution works, and in the interest of time, skip comments. If it works, it works. Yeah? Yeah. Yeah, so the question is, do I have to like write sentences about how pointers work or anything like that? And the answer to that is there are some kind of short answer questions of like, hey, explain why this doesn't work. That you will have to, explain something. Pointers could be involved in that. Or, variables in a function, returning more than 2 things. It could either be a short answer question or as part of the multiple choice or true false ones. Yeah?
Do you by chance know how the partial marks apply to these questions?
Yeah, so question, how does the partial marks apply for these questions? I mean, for this, I think in order for something like this, TA's just graded how many answers you got correctly. For the coding questions, basically it's like, there's typically like 3 to 4 different things you have to do. that give you all part marks for it. So it's like, I don't know. Let's argue about the average question. So for this, you know, maybe there's a few marks for this. Maybe there's 2 points for not truncating improperly, something like that. So you'd only lose partial points for that. If you didn't do that, you know, in this term, you know, we're just summing all the numbers together, so there's not much to screw up there. But maybe if this was something more complicated, it's getting that term correct is worth some part marks. It's generally how things are graded. And then, all right, so nothing else was standing. We got, oh, yeah.
I was just wondering, like, because the only one I saw that had like true and false questions was like 2024. Is there somewhere else that we could go for like more true and false practice?
So more true and false, I think that learningc.org book has a lot of true false on there. Yeah, I think that has a lot of true false. A lot of the true false are kind of, you know, smaller things like, hey, are these two things equivalent? Transforming things. Is this valid? Doesn't make sense. Some things you might be able to plug into a compiler, hopefully not. Things like that. Yep. Should you review the plenary lecture slides? I don't know. I haven't actually watched them. You should be good with everything I've done in the lectures and all the midterm stuff. Like the exam was finalized not that long ago, so I've read through it. It seems fine. Should be good to go. Yeah, there's nothing I haven't covered. I may or may not have given away some stuff today. Who knows? Let's see, there's another question. Yeah. So 2020, I don't have it offhand. Let's see. Let's see how fast the internet loads. So the request was for, let's see. Past exams, 2020, question what? Question 7. Oh yeah, 2020, question 7, this is a fun one. Basically, it was a cute trick. I think they went over like how numbers are represented. And the question is basically, if you haven't read it, I mean, I think that year like 10% of the class got it. So I wouldn't really worry about this question that much. I have a solution to it too. So the question basically states, I can't show you it because I don't have it loaded. Well, the question's basically like, what was it? Without using anything aside from a loop and without using size of or anything like that, figure out how many bits are in an int. And this has to do with kind of low-level details of how an integer is represented in memory, right? So when we went through that, I said that the most significant bit, that's the sign bit. So for their solution, they started with that value of 1, and then they just kept on multiplying it by 2 until the number flipped to negative. And then once the number flipped to negative, then they were like, okay, this is the last bit, so I know I'm at the end. So I actually have that as part of this. What was it? So it was called number of bits. So this was the solution to that. So the question is basically how many bits are in an int without using size of, which is silly because in the real world you just do size of times 8. Size of tells you how many bytes it is. How many bits is just times 8. But this is a cute one that pretty much no one got right. So the idea to this is we start with the value x equals to 1, and we just keep multiplying it until x flips to be negative. So it's just while it's positive, we keep on multiplying it by 2, count how many times we can multiply it by 2 until it flips to a negative number. So if we just run this, it was supposed to be short, but you know, you had to worry about how a number was actually represented in binary, blah, 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 probably outside of the, well, not outside of the scope, but Not something very nice to ask, but if you run this, it gives you 32, which kind of makes sense because we know an int is 4 bytes, and 4 times 8, so 8 bits per byte is 32, so it seems to work. But again, this question, most people got it wrong. It was kind of silly. Yeah? Yeah, so this, yeah, so in the case, like I kind of showed you the format of it at the, I think lecture 2 or lecture 1 or something like that, where it was the most significant bit and 0 means positive and 1 means negative. So in this case, if it sets int x equals to 1, that's, if we were to write it out in binary, it's all zeros except for the first column, which is a 1. And then every time we multiply it by 2, it just shifts that 1 to the next column, right? Until it eventually hits that sign column, in which case it would be like 1, and then who knows, but that would be some negative number. So this is basically what the code is doing. Just keeps on moving it column until the number flips to a negative, and then it's like, okay, I'm done. How many bits did that take? But again, yeah, this was 2020 question 7, right? So 2020 question 7, I wouldn't worry about it too much. Again, like I think 10% of that class got it. It was, yeah, that midterm was actually a bloodbath. Yours is not going to be a bloodbath unless, it's not going to be a bloodbath. Don't worry about it. But yeah, 2020 was a bloodbath. Yeah. Sorry? Was 2020 curved? So technically, we are not allowed to curve things because you can't, force anything into a bell curve, but we can adjust things if needed. So this is my second time doing this class. Last year, we did not have to adjust anything. Average for the midterm was somewhere between like 70 and 75, which is good. So you're the first ones doing it on Quarkus Online with the code editor, so that might be good, that might be bad. I don't know. It should be about the same. I expect probably something like 75-ish. But again, if you have any question, practice, practice, practice. I will be around extra late today. Again, that's outside my office, BA 5110. Other than that, I guess we can't do anything in 3 minutes, so good luck tomorrow. Your hardest task is going to be waking up at 9 a.m. and finding a desk and going to your assigned room and all that. So if you make it up, you've done the hardest.